Hello everyone. In this video, I will be starting the idea of permutations combinations, but before we move into that section, we will be talking about the idea of factorial notations and how it is related to arrangements. So first of all, before we start the discussion, it's like an objective or the goal of the session, the video is that we want to be able to answer this question after all, or this kind of questions. And then that also sets the tone or the context of what factorial notations and arrangement are all about. So it's all about finding out how many different ways, right? How many different ways that you see this, a number of different ways, number of different numbers, and so on, that we can form from a given objects or the given available information. So, but before that, further, so let's see what factorial notations actually are. Factorial notations can be written as, in this context, using n factorial, that's actually an exclamation mark, which means n times n minus 1 times n minus 2 times and so on until times 3 times 2 times 1. Or of course you can put it the other way around, 1 times 2 times 3 and so on until n. So for example, 5 factorial means 5 times 4 times 3 times 2 times 1 equals 120 after all. 7 factorial, same thing. 7 times 6 times 4 until 1, or you can do it the other way around. So some other examples that we can use to make things a bit easier is this. So for example, you have 10 factorial. So you can also put it as 10 times 9 times 8 factorial. Or you can put it as 10 times 9 factorial depending on what you need. So for example, you have also 12 factorial over, let's say 8 factorial. You can put it as 12 times 11 times 10 times 9 times 8 factorial, because you know 8 factorial is 8, 7, 6, 5, 4 until 1. So same is true for the denominator. You can put it as just 8 factorial, or you can write the detail. Then eventually you can cross out this. So then you're left with 12, 11, 10, and 9 all multiplied together. And then of course you can put it using calculator. You can calculate by yourself simply. So if we go back to the question in the beginning, so this is for example, the two examples that I will discuss here. Then you can try the first two questions that I posted in the beginning. So for example, how many different ways can we arrange 7 different books on a shelf? So simply what it means is that you have 7 books. For example, you have book A, B, C, D, E, F, G. So there's 7 books. And then you want to arrange them on a shelf. So of course, the idea is that you will have 7 spaces, right? Which I represent by 7 lines, the 7 underlines. That in the first position, like I'll put it like 1, 2, 3, 4, 5, 6, 7, like position number 1 until position number 7, from the left to the right. In the very first position on the left, then you can have any of the books, right? It means there are 7 possibilities over here. But then as you move on to the right, like in the second position next to it, now because you already put the first book over here, then now you only have 6 left. And you have 5 left, 4 left, 3 left, 2 left, and 1 left. So this idea that brings us to the idea of factorial notation, which we can put it as 7 factorial, or that means it's a 5040. If it's only 4 books, for example, that will be 4 factorial, or you can put it as 4 times 3 times 2 times 1, and so on. So you see that the idea of arrangement can be represented or calculated by using factorial notation. That's why I'm combining the two in this video as an example. So another example that you can see on the right side, this one, you can try it on your own if you want to think about it first. But this is how it will be done, or you can do it. You can pause the video if you want to try it by yourself. There are 3 girls, 3G, let's say you name it G1, G2, G3, and then there are 2 boys, right? 2 boys, let's say it's B1 and B2. They are to be seated in a row. Find the number of different ways that this can be done if the girls and boys sit alternately. What does it mean that they sit alternately? Is that it must be like girl, boy, girl, boy, girl. Then you should notice that you cannot start from the boy, Because if you start from the boy, for example, boy, then girl, then boy, and then girl, so you will be left with one girl that cannot sit anywhere because they can't sit here. She can't sit there because it will be not alternating. So the only possible way is that she must sit here, right, on the very left side. So then this is the only possible way to arrange them. But then you also know the way they are arranged. The girls can be swapped around, right? It can be the girl number 1, 2, 3, 1, 3, 2, and then 2, 3, 1, and so on. And then they're all different. And then that's the point of doing arrangements. The same is true with the boys. So then in this chapter, it's very particularly needed for you to know what numbers represent. So in this case, the way you arrange the girls, that will be 3 factorial. The way you arrange the boys, that will be 2 factorial. And then because the 2 are related, so you have to multiply the 2, not add. Okay, multiply, not add, because it's not a choice, but they are all connected into one setting of event. Move on with the question number B. A girl sits at each end of the row. What will be the case? So if you have 5 seats over here, there must be 2 girls over here, right? Because there are 3 girls, that means in between of them, there will be another 1 girl, right? This will be 2 boys and 1 girl. It's up to you how you want to sit, right? As long as the very first and the very last, there are 2 girls. So which means, in these 2 girls, you can pick, like, it can be girl 1, girl 2, right? Or you swap them. It can be girl 1, girl 3. It can be girl 2, girl 3. And you swap of them. It means it can be any of the 6, right? And then the way you arrange the remaining boys and girl, that will be just 3 factorial. Is that okay? So then that means it will be 6 times 3 factorial, or it means 6 times 6 will be 36. Last but not least, question C. The girls sit together and the boys sit together. So if you have 1, 2, 3, 4, 5. So it can be that the girls sitting here, G1, G2, G3, and the boys sit over here, right, on the left side, on the right side, sorry, B1, B2. Or you can swap it around. So the boy can start first, B1, B2, and then it can be continued with the G1, G2, sorry, G3, right? So it can be either of the 2. But then you should notice that each of them, the girls and the boys, they can be swapped around. It means for the girls to sit together, they are 3 factorial. But the boys, that will be 2 factorial. But at the same time, you can consider them as 1. Like as if there is only one person, as if there is only one person. So as if it's like you have 2 people that can be swapped. It means it will be another 2 factorial. So in total, you will be having 3 factorial times 2 factorial times 2 factorial, which means 6 times 2 times 2, so it's 24. Now you can repeat this video, of course, to try to make sense of what I'm talking about, and then after that you can try the remaining 2 questions over here that you want to try. The idea will be very much similar, but you may need to really think about it, especially for the second question. Okay, all the best.